Okay, so this is a physics problem dealing with one-dimensional kinematic motion, difficulty medium, with an object moving back and forth between a diminishing space. Okay, so we have three objects, A, B, and C. So A and B are closing in at each other, and C is running back and forth in between them. Now we want to know the distance that C covers when A and B meet each other. So again, A and B are moving towards each other, and C is running back and forth until A and B meet, wherever that is. Okay? So we have object A has a constant velocity or average velocity of 0.7 meters per second. Object B has an average velocity or constant velocity of negative 0.5 meters per second. And object C has a velocity of magnitude 3 meters per second. Now, the magnitude of a velocity is basically its speed. That just means that object C is going to be running back and forth with a speed of 3 meters per second. So the distance between them is 10 meters. Okay, so the first thing that we're going to want to do in solving for this is to figure out the time it takes when the difference in position between A and B is equal to 0. When the difference between the position of A and B is 0, that's basically when A and B meet. Okay, so we have the starting position of object A is 0, and we have the starting position of object B, which is 10 meters. Okay, so we're going to have our equation. So this is the final position of object A, and it's equal to the starting position plus the average velocity of A times delta t. Delta t is our time when the difference in position between A and B is 0. Now we have the final position of object B is equal to the initial position plus average velocity of B, and that's delta t, okay? Delta t is duration of time in which it takes for A and B to meet, okay? So now what we're going to do is we're going to set the final position of A equal to the final position of B. This means they're both going to have the same position. When they have the same position, the difference in position is going to be 0. Okay, so what we're going to do is we're going to take this equation and we're going to plug it in for the final position of A, and we're going to take this equation, the right hand side, and we're going to plug it in for the final position of object B. So then we have this, okay, reordering this equation to get similar terms on the same side. So over here we have velocity and delta t, and over here we have our positions of B and position of A. Plugging in the values for the variables gives us this. Now we have minus a negative. So when we have minus a negative, that's going to be plus, right? So we're going to have 1.2 meters per second, and delta t gets factored out and then put back in, right? And when you add these two together, okay? So now we have is equal to 10 meters minus 0. 10 meters minus 0 is 10 meters, okay? So our delta t is equal to 10 meters divided by our rate, okay? Our combined rate. Okay, so now we want to know the distance that object C traveled. Well, we take, in this case, the magnitude of 3 meters per second, right? Which is always going to be positive 3, okay? Which is basically saying that its speed is constant, 3 meters per second, throughout this duration, okay? So, basically, this is our ending equation, which gives us velocity times time is equal to a distance, which is what we wanted to solve for. Okay, now you can use a calculator and calculate that. That'll be up to you. So yeah, that's how you solve that. Any questions, feel free to leave a comment. If you liked it, please leave a thumbs up. Also, if you want me to solve another question, like I said, leave it in the comment section. I'll be happy to solve as many as I can for you. Okay, thank you. Bye.